Building or ordering a custom PC can be a daunting task. With so many components that comprise a computer these days, it's hard to make sure that you choose the right one for your particular usage scenario. In this video series, I'm going to highlight core components and indicate key features and factors that matter when choosing components so that you have an easier time when doing it yourself. I'm David with Adamant PC, and in this video, we'll be talking about power supply units or power supplies. Key factors that are worth taking into consideration when choosing a power supply is the output wattage of the power supply, the efficiency of the power supply, and the modularity of the power supply, as well as any cables that the supply does or does not include. The wattage of the power supply is a number that indicates the maximum output power that the unit can deliver to the components inside of the machine. Every power supply operates on a few voltage rails. Here's a chart that lists the main voltage rails that you'll find in a modern PC, as well as the components that typically use those voltage rails to receive power. As you can see, the majority of the components that you will be considering when purchasing and configuring a PC will be using the 12 volt rail. So when you're looking at a power supply's wattage, you want to make sure that the vast majority of that power is getting delivered through the 12 volt rail. That way your components are sufficiently powered. The critical role of a power supply is to accept alternating current from your wall and then convert it into DC power for your components. The ratio at which energy is drawn from the wall versus what's delivered to the system is referred to the efficiency of the power supply. Unfortunately, we live in an imperfect world, and so no power supply is 100% efficient, but there is a specification that can help you determine which power supplies are better than others in that regard. The 80+ certification is an indicator of overall performance for the power supply, as well as referencing its efficiency. There are a few 80+ designations or certifications. There's 80+ standard, 80+ bronze, silver, gold, platinum, and titanium. And as you ascend that list, generally speaking, the higher quality the power supply is. It is also important to be mindful of what power connectors your components need and in what quantity they need them, because typically the more power that a component requires, the more power connectors that component needs as well. So for example, with higher end desktop processors like AMD's Threadrippers or Intel's Extreme series, you'll often find that the motherboards require multiple CPU connectors, whereas most consumer grade power supplies and motherboards only require or even have just one. So you really want to make sure that when you're choosing your components, you have all of the proper cables that you need in order to power them. Otherwise, you're either going to have to try using splitters, which might not work too well, or have to buy a completely different power supply. In most modern machines, your processor and your video card are going to consume the most amount of power. With processors, there are two main kinds. There are consumer grade processors. Those are your Core i3s, i5s, i7s, or your R3s, R5s, R7s, and high-end desktop processors like Intel's Core i9 Extreme series and AMD's Threadripper lineup. And these have very different power requirements. On the consumer side, you're typically looking at anywhere between 65 to 95 watts on the Intel side, or 35 to 105 watts on the AMD side. And then in that higher end desktop territory, you're going to be looking at around 140 watts to 165 watts on the Intel side of things with the Core i9 Extreme series, and up to 250 watts with AMD's Threadripper 2990WX series processor. With video cards, on the consumer level, you're looking at anywhere between 50 to 275 watts of power needed for the component. On the NVIDIA side, it starts at around 30 watts with NVIDIA's GT 1030 and caps out at around 175 watts for the reference design of a 1080 Ti. On the AMD side of things, for modern GPUs, the RX 550 consumes about 50 watts and goes all the way up to 295 watts with their Vega 64 GPUs. Your workstation or prosumer GPUs typically consume less power than their consumer or gaming counterparts, and so you'll be looking at a TDP range of around 40 to 250 watts with those types of GPUs. Key reasons to buy higher efficiency power supplies is if you're going to be overclocking, because those higher efficiencies typically come with higher and more, strict voltage and power regulations that can result in higher and more stable overclocks. It saves you money on your electric bill, so if you care about that, higher efficiencies can save you money when you get your your electric bill in. And if you're going to be having your machine running for a longer than average amount of time, higher efficiency power supplies typically come with higher quality components inside that can have more continuous runtime and take a heavier beating than lower efficiency power supplies can. For your home and business PCs, you should be looking at anywhere between 450 to 650 watts of power. You really won't need more than that unless you were to start overclocking that rig or adding video cards to it to repurpose it for like a gaming machine or to get it into workstation territory. But if you're keeping it fairly standard, so to speak, then 450 to 650 watts should be fine. Gaming PCs typically have power supplies that range from 650 to 850 watts, though you can go higher if it involves multi-GPU setups or intense overclocking. So depending on what your particular machine is doing, you might go over, but more than likely you'll be sitting anywhere between 650 watts with the mid-range options like an i5 and a 1060, and 850 watts with something like an i7 and a 1080 Ti. Workstations can require anywhere from 750 or lower in some instances, all the way up to 1600 or higher, depending on how the machine's being configured. If your applications are going to be very CPU bound and doesn't really require a lot of GPUs to be effective, then having a lower wattage power supply is totally fine. But if you need 4, 5, 6 GPUs inside of a rig for 3D video rendering, for example, then having a 1600 watt or higher power supply, or even multiple power supplies, would be necessary. This video is sponsored by Thermaltake. Their mission is to deliver the perfect user experience through the enjoyment of entertainment, esports, technology, and lifestyle. They offer a vast selection of computer components and peripherals, including power supplies. Excellent performance, design, and reliability goes into every Thermaltake product. Courage, passion, and perseverance makes up their DNA. Explore what they have to offer at thermaltake.com. Well, that's it. So hopefully you took away some valuable information from this video. And if you have any questions, please feel free to email me at david@adamant.com, and make sure to visit our website, adamant.com. I am David with Adamant PC, and I hope that you have a phenomenal day.